So we finished off our last one with being able to say whether there's two roots, one root, or no roots. And so we've done this whole this question now. Now we actually want to print out what the roots are. So what's the answers for these equations? And so I'm going to go and edit this code and then to actually do that. So I'm going to come in here. So the equation root 1, so we'll call it root 1. So this is if it's got two roots, so I'll call root 1 and root 2, and we're going to make them equal to stuff. So first of all we'll do negative b plus the det, or square root of the det, so I'm just going to do to the power of half. So that's minus b plus that det thing, which goes in the square root bracket of our quadratic equation, or quadratic solution, or whatever. So we have that on the top divided by 4, wait, what is it, 4a, or 2a. So that's our root 1, because we got plus det. And then, so our root 2 will be, and that's minus. So remember, it's the plus or minus. I wish there was a better way to show you, but if you know the quadratic equation, it's minus b plus minus root b squared minus 4ac. So that's essentially minus b plus minus square root of the determinant divided by 2a. So we've got our root 1 and root 2 there. So I won't print it out yet. I'll do this next one here. So this next one, I'll copy this. So when it has only one root, so I'll copy this. But our det's going to be equal to 0, because that's what we got. If det is equal to 0, so we can just kind of take away this whole det thing, because this square root of det will be equal to 0. So then I'll take away the brackets as well, because we don't really need them there. So now it's just our root is minus b divided by 2a. Okay, so now we've calculated ours. Okay, I'm just going to change some stuff. I'm just going to write, instead of writing det is less, let's say there are no real roots. And then I'll change this one. So we want a one root that is, and then we'll do percentage, and then I'll do 2 decimal places, so dot 2 and then f. Okay, one root that is dot 2 dot f. Wait, what was that? Oh, it's 3.9 degree. Okay, and now we have to put in root 1. So that's what it's going to say. So it says one root that is this. Okay. Now we're going to do the same sort of thing up here. So I'm going to write 2 roots and then new line, root 1 equals, and then I'll do this percentage, and then again I'll do 2 decimal places, 0.2 f, and then I'll do a new line, and then I'll do root 2 equals percentage 0.2 f. So that's just the 2 decimal points after, or 2 decimal places after the decimal point. And so now we have to put in order of what they occur. So our root 1, our percentage f thing here is going to be root 1. I might call this something different just so it's not confusing for you. So just call that root. It's root 1 and then root 2, which is the second one that occurs. So that's really all we have to do to modify it, to get it displaying the roots. This here is just the algebra behind it. These two are just getting the actual roots from entering it into the formula and then printing it out. It's we've seen this in the first part of this sort of course. So again, same logic that we had before, just now we actually calculate the roots. So let's give this a go. So input a value for a. So I'll do one that I've done before, so the 2, 5, and 1. So a is 2, b is 5, and c is 1. So it says there's 2 roots, root 1 is equal to negative 0.22 and root 2 is negative 2.28. So there we go. That's working. I'll try to do another one that's like a perfect square. So we have a equals 1, b equals, what does b equal? B equals 4 and c equals 4. There's one root and it's negative 2. Okay? Good. So you could work that out. If we did the same sort of thing, we did so we have another perfect square. We'll have a equals 1 and then b equals negative 4 and c equals 4. The root is 2. So that's the equation. That's it. So you can see how useful this could be if you're actually writing a program that you want to work out the roots. Just pop it in and it spits it straight out. And that's the second part of the quadratic roots.